Hi guys, coordination compound, most important 100 MCQs let's discuss in this session. Coordination compound is an entirely different chapter compared to the other concepts. The IUPAC nomenclature of coordination compound, their types of ligand, how to calculate the oxidation state of the metal and how to calculate the coordination number. That different theories are there, Werner's theory, valence bond theory, crystal field theory, application of coordination compound, why they show color, why or what is a stability order, spectrochemical series, lot of concepts, isomerism, right? Many concepts are there from the chapter coordination compound. So let us discuss about the 100 most important question from the chapter coordination compound. I hope we can cover the entire theory also. Ready? Question number 1. Which of the following is the coordination entity in this one? You know what is meant by coordination entity is also called a coordination sphere, the bracket. The square bracket, the square bracket contains central metal atom and ligand. That part is called what? Coordination entity or coordination sphere. And the one which is present outside the bracket, that is called it as counter ion, right? Counter ion. So here this is the coordination entity or coordination sphere. Yes, D is the answer, right? In a coordination sphere or in coordination entity, we have the central metal atom first, then we have ligands. Correct. Second question, the central metal atom of a coordination complex is also referred to as. For example, let me consider FeCN6 4 minus. Here, which is the central metal atom iron, right? This is considered as what? Whether it is a Lewis acid, Lewis base, Bronsted, like that. You may study the Lewis concept and Bronsted concept in 11th grade. What is a Lewis acid? Lewis acid is a electron pair acceptor. Electron pair acceptor. What is a Lewis base? Lewis base means electron pair donor. Electron pair donor. And what is meant by Bronsted acid and Bronsted base? Proton donors are acid, proton acceptors are bases. Here proton concept is not in our coordination compound. They are electron transfer is electron pair donor and electron pair acceptor is there. Ligands. Ligands are electron rich. They are donating electron. So their ligands are Lewis bases. Generally Lewis bases are which one? Ligands. And the central metal atom, they will accept the pair of electron. Therefore, the central metal atom belongs to which one? Lewis acid. So, generally ligands give electron. Therefore, they are Lewis bases. And metals gain electron here. Therefore, they are Lewis acids. Okay. Next one. Identify the Lewis acid in this complex. Lewis acid means what? The central metal atom. Which is the central metal atom here? Aluminium. Whether it is aluminium or aluminium 3 plus, my dear, check it. What is the charge of aluminium in this case? Potassium charge is +1. So 3 potassium plus 3, aluminium X. And this is oxalate. Oxalate charge is -2. So 3 oxalate is -6. Overall 0. X is equal to +3. Yes, here aluminium is in what charge? +3 charge. So that is the Lewis acid in this one, or the central metal atom in this complex. Next one, which of the following is the central atom ion in this complex? Which is the central atom here? Cobalt. But what is the oxidation state that we have to know? We don't know what is cobalt oxidation state. Let us take it as X. Chlorine charge is -1. Amine is a neutral ligand. Overall charge is +2. So we will get X is equal to +3. Yes, cobalt in 3 plus state in this one. How to, I hope you all, my dear student, know how to calculate the oxidation state of the metal. What is the charges of each and every ligand, correct? Next one, which of the following cannot be a ligand? Which of the following cannot act as a ligand? Ligands are either negatively or neutral charged species, right? Ligands are negatively or neutral charged species. Of course, which one? Nickel 2 plus, right? Nickel 2 plus is a metal. It's having positive charge. Ligands are negatively or neutral charged species, right? Yes, this is negative charge. This is neutral charge. See, because of the lone pair, they're electron donating one. Now, how many donor atoms can EDTA 4 minus ligand bind through? What is EDTA full form? My dear, EDTA is what? Ethylene diamine tetra. Tetra means 4. What? Acetate. CH2COO minus, CH2COO minus. CH2COO minus, CH2COO minus. This is the compound called EDTA, ethylene diamine tetraacetate. We studied in classes, if there is a metal atom present, how many donor atoms are present in a EDTA? Negatively charged positions are donor atom because they are electron rich. Negative indicate that electron rich. It is 4 donor atoms are there, but not 4 is the answer. 6 is the answer because nitrogen contain lone pair, my dear. That is also donor atom. So one EDTA can donate 6. That is 6 donor atoms are present. So answer is 6 and 6. And EDTA is considered as a hexadentate ligand because there are 6 donor atoms. So EDTA we studied under polydentate ligand, EDTA having 6 donor atom, therefore it is considered as a hexadentate ligand. Answer is 6. What is the coordination number of the chromium in this one? What do you mean by coordination number? Coordination number mean it is the number of sigma bond around the central metal atom. See here the central metal atom is chromium, right? It is surrounded by C2O4. What is C2O4? Oxalate. Oxalate, how many are there? 3 oxalate are there. You know very well, oxalate is a bidentate ligand. So 1 OX provide 2 sigma bond. So total 3 OX will provide 6 sigma bond, my dear. So what is the number of sigma bond? 1, 2, 3, 4, 5, 6. So 6 is the coordination number. What do you mean by coordination number? It is the total number of sigma bond around the central metal atom which is created by the ligand. OX, C2O4 is OX. That is oxalato. Oxalato is a bidentate ligand. So 1 OX provide 2 sigma bond. So this is the maximum sigma bond. Identify the coordination sphere in the compound. What is coordination sphere? This one. Coordination sphere means the square bracket. It's also called coordination entity, my dear. Option C is the correct answer. Here K4. What is K? Potassium that is outside the bracket. That is called the counter ion. Okay. So counter ion, and this is the coordination sphere. Next one, what is the sum of the metal coordination number, sum of coordination number and oxidation number of this metal? See, this is the metal. Let us calculate the oxidation state. Let me calculate first. Metal X, En, charge is 0, neutral ligand. C2O4, 1 oxalate charge is -2. Yes, overall 0. So X is equal to +2. So 2 is the oxidation state. Let us calculate the coordination number. Metal is there. En twice. En is a bidentate ligand. So 1 En provide 2 sigma bond. So 2 En provide 4 sigma bond. And C2O4 is our oxalate. That's also a bidentate ligand. Total 6 coordination number. So oxidation state 2, coordination number 6. Overall, what is the sum? We can write 8 is the total sum. Okay. So they're asking you what is the sum of the coordination number and oxidation number. Coordination number is 6 here and oxidation state is what? 2 here. Okay, dear all. Next one, when silver nitrate in excess is treated with the complexes COCl3 6NH3, COCl3 5NH3, COCl3 4NH3, their molecular formula is given. The right order of the stoichiometries of AgCl produced is this respectively. Let me take this complex first. Cobalt is the metal atom. See, 6 amine is there, right? 6 amine and 3 chlorine is there. You studied a spectrochemical series where amine and chlorine, when you consider which is the most strongest ligand, amine is strongest ligand. Always amine, the strong ligand form the bond initially first, okay? So strong ligand you add first. So what is a strong ligand? Amine. How many times are the NH3? 6 times. And close the bracket and the remaining 3 chlorine outside. Keep in mind, maximum you can place 6 ligand inside. Maximum coordination number possibly 6, okay? Remaining all put it outside. So this is the first complex possible. What about the second complex, dear all? The second complex is COCl3 5NH3. It's only have 5NH3. So let me place 5NH3 first. Then 1 chlorine I can put it inside because maximum you can place 6 inside. So 5 plus 1, 6. Remaining 2 chlorine outside. Okay. What about the last one? Only 4 NH3. So CONH3 4 times. Cl2. This time I can place 2 chlorine inside because 4 plus 2 total 6 you can place inside and 1 chlorine outside. And this compound they are treating with what? they are treating with a silver nitrate, right? They are treating with a silver nitrate. If you treat it with a silver nitrate, this AgCl combined, you will get AgCl. So here 3 chlorine outside, all counter ion can undergo reaction. So here 3 chlorine outside, it will give you, first one give you 3 AgCl. Second one 2 chlorine outside, so it will give you 2 AgCl. Last one only 1 chlorine outside, so it will give only 1 AgCl. So you will get 3 to 1 AgCl from these compounds. So what all things we have to be careful to answer this question, my dear? Inside the sphere, maximum you can place 6 ligand, which means 6 coordination number. Remaining all you should keep it outside. And the strong ligand always you should put it inside. Okay, strong ligand always bond first. Then how many chlorines are outside? Same amount of AgCl you will get it. Here 3 chlorine outside, therefore 3 AgCl. 2 chlorine outside, 2 AgCl. 1 chlorine only outside, 1 AgCl. Like that. 1 AgCl, okay? AgCl. That's not AgCl to AgCl. Next question. Isomerism in the FAC and MER. Okay, we studied FAC and MER isomer. And along with the meridian will be demonstrated. We studied that FAC and MER isomerism is given by the complex octahedral complex, my dear. Octahedral complex is giving you the FAC and MER isomer with the type Ma3B3 type. Ma3B3 type. The type Ma3B3 shows FAC and facial and meridian isomerism. Which is that type? I think it is option A, Ma3B3 type. That's it. And this you think this is Ma4B2, this is Ma6, right? Ma6 means because En is a bidentate ligand. So 3En means it will be 6 site, okay? And this is Ma5B. No. FAC and MER isomer is only given by the type Ma3B3. That is option A. Which of the following has the highest molar conductivity? Keep in mind all of you, the one which is giving you more ion, their molar conductivity increases. The one which is giving more number of ions, it can conduct more electricity. So let me take you how to write their ions. Dear all, this complex is only the coordination sphere. Coordination sphere do not dissociate, do not break, that won't give you any ions. So no ions here. What about this one? This complex breakdown as CONH3 4Cl2 plus and Cl minus. See this compound you please treat it as NaCl. NaCl how it break? Na plus and Cl minus. Same way this complex plus and Cl minus. Okay. And what about K4FeCN6? It break as how many potassium outside? 4 potassium outside. So it will give you 4K plus and FeCN6 4 minus. So total 4 plus 1 you will get how many? 5 ions you can get it. How many ions here? 1 plus 1 only 2 ions. What about this compound? What about this compound? You considered as this is what? AlCl3. How you break AlCl3? Al3 plus and 3Cl minus. Same way, this is Al, this is Cl3. We will get CrH2O thrice 3 plus and 3Cl minus. Total how many? 1 plus 3 total 4 ions. The one which is giving more number of ions can conduct more electricity. So option C is the one giving 5 ions. So that's having more conductivity. Okay, clear all? Molar conductivity. So the one which is giving more ion can conduct more electricity. Next one. Atomic number of chromium, manganese, iron, cobalt and all given here. Which of the pair with the same magnetic moment? Magnetic moment is calculated by the equation root of n into n plus 2. The unit you know, Bohr magneton. Magnetic moment nu is equal to root of n into n plus 2. You know what is that n? N is the number of unpaired electron. So where number of unpaired electrons are same, where magnetic moment also same. So you want to calculate the, let me check it, option A, okay. Which is the central atom? Chromium. Chromium, you know, atomic number 24. Normal configuration, right, like argon 4s2 3d4. You know, our chromium, there is an exception case. Anyway, you are going to lose electrons, so no need to make. Chromium here charge is which one? 2 plus. So chromium 2 plus mean these 2 electron gone. What is remaining? 3d4 is remaining, right? 3d4 is remaining. After getting 3d4, you know, chromium is the H2O is a weak ligand. So pairing won't happen. So the 4 electron exists as what? 1, 2, 3, 4. 4 is the unpaired electron. But what about this case? This pair is given as cobalt. You know, cobalt atomic number is 27. Configuration is argon with 4s2 3d7. Here cobalt charge is also, when you calculate, you will get 2 plus. So this gone. So what is remaining? 3d7. Water, chlorine, you know, halogens are weak ligand. Electrons won't undergo pairing. So 7 electron, how it is existing? 1, 2, 3, 4, 5, 6, 7. Here only 3 unpaired electron. Here 4 electron, here 3 electron. Definitely their magnetic moment won't be same because their number of unpaired electrons are different. So let me check it with the option B. Option B, I think the first case is similar. Okay, here N is equal to what? 4. Let me check the second one. You know, Fe atomic number is 26. So configuration is what? Argon 4s2 3d6. And Fe charge is also here 2 plus. So this 2 gone. 3d6 is there. 3d6 mean how you write the electron, my dear? 1, 2, 3, 4. Yes. In these two cases, number of unpaired electrons are same. Number of unpaired electrons are same mean their magnetic moment also same. I think option B is the correct answer. So where magnetic moment is same means they having same number of unpaired electron. Which one having higher magnetic moment if they asking you where number of unpaired electrons are higher in number. Next one, what is the correct order of the field strength? You know, the spectrochemical series, weak ligand to strong ligand, the arrangement you may study. Which is the correct order of the spectrochemical series? Many times this is a repeated question, my dear. Tell me which is the correct order of the ligand. You know, carbonyl is the strongest ligand, then cyanide, then ethane 1,2-diamine, then amine. Option A is the correct answer. Please study all of you the spectrochemical series. Then the chelate effect is the stabilization, right? You know, chelating ligands are there in the complex. Yes, what is chelating ligand? They are bidentate or polydentate ligand. If there is chelating ligand in your complex, yes, we studied that, they can form which one? Stability. And which of the following complex species is the most stable due to chelation? Which is a chelating ligand? Option C, dear all, oxalate is there. What are the bidentate ligand we studied? Oxalate and En, right? So in order to form chelation, what is required? Bidentate or polydentate ligands are required. You know, these all are what? Monodentate ligands. Then coordination compound exhibit isomerism due to the presence of ambidentate ligand. Which one? Linkage isomerism, right? Linkage isomerism. If the coordination complexes contain the, which one? The ambidentate ligand, they can show linkage isomerism. See all of you, palladium C6H5 twice, SCN, you know, SCN is an ambidentate ligand, thiocyanate. Its pair is which one? NCS. Their connection is different, right? Here palladium connected to sulfur, here palladium connected to nitrogen. That is called what? Linkage isomerism. Then what is the IUPAC name of the complex? You can able to see amine is there, bromido is there, nitrito, N is there, chlorido is there. Alphabetical order, what we can write? Amine, right? 3 amine are there. Therefore, triamine, then bromido, yes, then bromido. Then chlorine is there, chlorido. What is NO2? Nitrito N. Who is the metal? Platinum is the metal, platinum. What is the oxidation state of platinum, my dear? Platinum, take it X, amine 0, 1 bromine -1, NO2 -1, chlorine -1, even outside 1 chlorine is there -1, overall 0. You will get X is equal to what? +4. Yes, we are getting 4 and outside counter ion, don't forget to write chloride, right? Chloride, which is the most suitable answer. Check it all. Triamine, you know, chlorido or chloro we can apply, okay? Similarly, bromido, bromo. So triamine, bromido. So this is not correct. Triamine, bromido, chlorido, nitro. Nitro means nitrito N, or sometimes they used as what? Nitro. Platinum for chloride. Yes, option C is the most one. As per the rule, it is correct. Now, what is the primary and secondary valency of platinum in this one? You know, according to Werner's theory, primary valency gives the oxidation state. Primary valency gives the oxidation state. Secondary valency give you the coordination number. So calculate the oxidation state and coordination number. Here platinum oxidation state X, En is a neutral ligand, 2 chlorine minus 2, overall 0, X is equal to plus 2. So 2 something, that is option D. Correct. And what is the secondary valency? Here platinum is the metal, En is a bidentate ligand. So 2 En give you 4 bond and 2 chlorine are there. Total how many sigma bond? 6 sigma bond. So 2 and 6 is the primary valency and secondary valency. I mean, and you studied that primary valency is also called ionizable valency. Secondary valency is also called non-ionizable valency. That's also be careful. Which of the following has magnesium? Magnesium. We studied in our application part, in biological system, coordination compounds are present. For example, hemoglobin, iron is the central metal atom. Chlorophyll pigment, magnesium is the central metal atom. Vitamin B12, cobalt is the metal atom. So where is magnesium present? That is in chlorophyll, my dear. Hemoglobin, what is the central atom? Iron. And vitamin B12, cobalt, like that we studied in our application part. Then a chelating agent has 2 or more than 2 donor atom to bind to a single metal ion. Yes, they are bidentate or polydentate. Which of the following is not a chelating agent? Not a chelating agent. You know, thiosulfato. Thiosulfato, let me write it as, mostly they give you thiocyanato. Okay, mostly they give you what? Thiocyanato. What is thiocyanato? SCN. Then what is oxalato? You know, C2O4 2 minus. What is glycinato? You will study in biomolecule chapter glycine, where glycinato is what? NH2CH2COO minus. And ethane 1,2-diamine, that is our EN, right? Ethane 1,2-diamine is our EN ligand. Question. Which of the following not a chelating ligand? You know, thiocyanate is a what? It is a ambidentate or monodentate ligand. It cannot form 2 bonds at a time. Whereas oxalate is a bidentate ligand, En is a bidentate ligand. Here you see this nitrogen and this oxygen. Yes, 2 donor atoms are there. So SCN, thiocyanato is which one? A monodentate or ambidentate ligand. So they form only single bond. So cannot form ring, right? What is the IUPAC name of the complex? Dear all, amine is there, chlorine is there, nitrito N is there. 2 amine, right? There are 2 amine. So let us start all of you. Diamine, right? Diamine, chlorido, and what is NO2? Nitrito N. Then which is the central metal atom? Platinum. There is no counter ion, write the oxidation state. Platinum oxidation state X, amine is 0, chlorine is -1, and NO2 charge also -1, overall 0, X equal to +2. Where is the answer, my dear? Diamine, chlorido or chloro, nitrito and platinum 2. Yes, option 3 is the correct answer. Please cross check it, all of you. Okay. In the complex, you can able to see there is a complex given. En is ethylene diamine, okay. Dash are the coordination number and the oxidation state. They are asking you coordination number first, oxidation state second. What is the coordination number? E is the metal, En are 2 time. You know, 1 En provide 2 sigma bond. So 2 En provide 4 sigma bond. And oxalate is also there. Oxalate is also bidentate. Total 6 sigma bonds are there. So starting 6. Then what is the oxidation state? E charge is X. En is neutral ligand. Oxalate is -2. Nitro is -1. Overall 0. X is equal to +3. So 6 and 3. Where you can see, my dear, option 4, 6 and 3. See how many questions are repeated. They ask you the oxidation state and coordination number. Okay, careful. The type of isomerism shown by the complex is, what is this complex? First of all, you have to judge it. What complex is this? This is octahedral. How you can judge it octahedral? Coordination number should be 6. Then it will be octahedral. See here, cobalt is there, right? Cobalt. Cobalt connected to 2 chlorine. Yes, 2 chlorine. And En is there. En means what? 2 En mean it will provide total 6 are there. 6 is the coordination number, that means it is octahedral. You know, octahedral, what is this type? This type is Ma2B4. Ma2B4. Why B4? Ma2, you know, En is a bidentate ligand. So, one En provide 2 side. So, 2 En provide 4 site. Therefore, B4. Ma2B4 octahedral complex shows cis trans isomerism or the geometrical isomerism, my dears. If it is octahedral, if it is a type of Ma2B4 or Ma4B2, then it will show cis and trans isomerism. That is also called what? Geometrical isomerism. Keep in mind. Hemoglobin is a complex compound of which metal ion? We discussed that hemoglobin contains ferrous ion. Ferrous. Which one? Fe2 plus. The complex ion, you can able to see two complex here. What type isomerism is this? Very simple. A nitrito N is there, nitrito O is there. If there is a chelating ligand, yes, it will show which isomerism? Linkage isomerism. So that points are, I hope it is clear. Here we have the question number 26. What is more salt? We studied more salt is a double salt, right? More salt is a double salt. More salt contain ferrous sulfate. Double salt in the sense it's a combination of two salt. More salt contain ferrous sulfate. What is ferrous sulfate? FeSO4 and ammonium sulfate NH4 twice SO4 along with 6H2O. Note it all of you, more salt is a double salt which contain ferrous sulfate and ammonium sulfate. And where we studied more salt, we studied what is the difference between a coordination compound and double salt. Coordination compound do not undergo complete dissociation in water or in solution, whereas double salt undergo complete dissociation. So what is chemically more salt? FeSO4, NH4 twice SO4 along with 6H2O, option B. EDTA is used for the estimation of. We studied in the last part the application of coordination compound. EDTA is used in the determination of hardness of water. Hardness of water, right? EDTA is used for the quantitative analysis, checking the hardness of water. They are asking you what is hard water. You know, hard water contain calcium and magnesium ion, right? Calcium and magnesium ion. EDTA is used for the quantitative analysis. Which one? Checking the hardness of water. Then the solution of the complex, this complex, what is the complex given? CuNH3 4 times SO4 in water will give the test of copper ion NH4. Very simple, my dear. Very simple. See, copper and amine, they do not come out. Sphere do not break. Only what is present outside, that is counter ion. Counter ion can undergo complete reaction. So it can give you the reaction of which one? Sulfate ion. Give the test of sulfate ion. For example, if you treat this compound with a barium chloride, this barium combined with the sulfate, you will get barium sulfate white precipitate. White precipitate. Remember, only counter ion can undergo complete reaction. Okay. Now, consider the following isomers. You can able to see so many compounds are given here. In this, consider the following isomer. Which of the following observation is correct? Okay, correct. Let me check it once again. Which of the following observations are correct? First one, give a pale yellow color. See, this all are not isomer actually. See, the formulas are having difference here. So, these two are okay. Anyway, first one will give pale yellow. And second one will give white precipitate with a silver nitrate. Is it? You know, if you treat it with a silver nitrate, you will get this AgBr. Yes, AgBr color is yellow color. If you treated this with the AgNO3, you will get AgCl. Remember all, AgCl color is white color. So first one give you pale yellow and second one give you white precipitate with a silver nitrate. Yes, that is correct. A is the correct one. Remember, AgBr color is yellow color, AgCl is white in color. Now, the number of ions given by this complex in aqueous solution is, yes, it is compulsory to know how to break into their ions, my dear. Carefully listen. Carefully listen. You know how to break into their ions. This is complex, right? This complex you please don't treat it as a big compound. This is just one species, one ion. So this complex I can write 1 time and chlorine is already 4 time. And you know this 1 come from chlorine and this 4 come from this one, right? You know the ions making first one cation, second one anion. So we can write 1 this complex. What is the complex? PTNH3 6 time 4 plus 4 chlorine with a charge -1. Total 1 plus 4, total you are getting 5 ions. So what is answer? 5. The number of ions given by this complex is which one? 5. That's it. When 1 mole of each of the following complex is treated with the excess of silver nitrate, when this complex is treated with the excess of silver nitrate, definitely you will get AgCl because this Ag combined with this Cl, right? The outermost Cl, which will give maximum amount of AgCl. Very simple. Where maximum chlorine outside, that will give you more AgCl. Here 3 chlorine, here 2 chlorine, here 1 chlorine, here no chlorine. So which will give, this will give you 3 moles of AgCl. Remember, how many chlorine are present outside? Same amount of AgCl can get it when you treat it with a silver nitrate. Complexes in increasing order of their conductivity. Already we discussed the one which is giving more number of ions can conduct more electricity. See, this is only coordination sphere. It won't give any ion. And this complex is just like a NaCl. You consider 1. So this complex is CONH3 4 times Cl2 plus 1 and Cl minus 1. 1 plus 1, total it's giving you 2 ions. Dear all, this is just like a NaCl, okay? This is, you consider this one as Na, this is Cl. It will give you Na plus Cl minus, like that, this plus this Cl minus, that's it. And this one we can write it as complex, this 1 time, this 3. You know, this 3 come from this side, the 1 come from this side. So you will get 1 complex with the CONH3 6 time 3 plus 3 Cl minus 1 plus 3, total it's giving you 4 ions. What about this case? This I can write complex 1. This 2 come from here, this 1 come from here. So 1 complex CONH3 5 times Cl whole 2 plus 2 Cl minus, total 1 plus 2, it's giving you how many? 3 ions. Here no ion. The one which is giving more number of ion can conduct more electricity. So what is the order, my dear? Third one is the highest. Third one is the highest. Then fourth one. 3, 4, 2, 1. Yes, option A. The one which is giving more number of ions can conduct what? More electricity. So third one is most highest because third one having more ion than the fourth one, second one. Correct. A coordination compound having the formula CrCl34H2O. So chromium is the metal atom. Chlorine and aqua can be the ligand. It gives a white precipitate of AgCl with a silver nitrate. The molar conductance of the compound corresponds to 2 ion. It's giving you, the complex is giving you 2 ion. And what is the complex? Very simple. Which is giving 2 ion here. See, this won't give you 2 ion. This is only the complex. Cut it. And they already said it will give you AgCl. Will it give AgCl? No, there is no chlorine outside. Cut it. It can give you 1 AgCl. It can give you 2 AgCl because 2 chlorine outside. But they said overall the complex will give you 2 ion. Yes, this one. This complex, how you break, my dear? This is 1, right? This is CrH2O 4 time Cl2 plus 1 and Cl minus C1 plus 1, total 2 ion. 2 ion is given by option C. You check it with this one, it will give you 3 ion because 1 complex and 2 chlorine, 3 ions are produced. They already said 2 ions should be formed. According to Werner's theory, what is Werner's theory? According to Werner's theory, they said the central metal atom possesses 2 types of valency, primary valency and secondary valency. Primary valency give you the oxidation state and secondary valency give you the coordination number. Primary valency is also called ionizable valency. Secondary valency is also called non-ionizable valency. So first one question, according to Werner's theory, primary valency is ionizable. Yes. Secondary valency is non-ionizable and primary valency, both are not. No. So primary valency is ionizable, secondary valency is non-ionizable. Fill in the blanks according to Werner's coordination theory. There are dash kind of valency. There are 3 different to 2. There are two type of valency, my dear, primary and secondary. So there are two type of valency. So answer is either C or D. Dash and dash, that is what primary and secondary. Primary and secondary. Primary valency of a central metal ion satisfy with what? Primary valency. Primary valency means what? The oxidation state. Oxidation state depends on what? The charged ligand. That means anions, right? So, two primary, secondary, anion. See, cation is not possible, right? You know, the primary valency means what? Oxidation state. When you calculating the oxidation state of a central metal atom, we need the negatively charged ligand, because neutral charged ligand won't contribute any charge to the oxidation state, right? Now, ammonia act as a very good ligand. You know what is ammonia? NH3. You know, it act as a very good ligand because it can donate the lone pair. It's electron rich. Whereas ammonium ion, what is ammonium ion? NH4 plus, do not form complexes. Why? Simple question. You know, ligands are either negatively or neutral charged species. Positive charge is not allowed, right? So ammonia, why it is a ligand means because it's having lone pair, it can donate to the metal. Amine is a gas, no. Ammonia undergo sp3, no. Ammonium ion does not have any lone pair, yes, therefore. Ammonium ion does not carry any lone pair, but ammonia that contain lone pair. A ligand is given here. Let me just expand, my dear. This N, CH2, CH2, NH2. Like how many are there? 3 are there, right? CH2, CH2, NH2. And we have one more CH2, CH2, NH2. All right. These are the 3 ions given here. This is a ligand given. What is the density? How many donor atoms are there? That's a question. See dear, all nitrogen carry lone pair. All are donating site. You check whether there is a negative charge or neutral charge. Neutral charge in the sense there's contain lone pair or not. Those sites are donor atoms. So 4 lone pair is available. So 4 donor atoms are there. So it is a tetradentate ligand. Now, among the following, which are ambidentate ligand? You know very well what are ambidentate ligand. Ambidentate ligands are certain monodentate ligand having 2 donor atom, but at a time they use only once. You know, CN, NC are ambidentate ligand, SCN, NCS ambidentate ligand, and we have a NO2 and ONO as ambidentate ligand. Which of the following are ambidentate ligand? SCN, NO3 no, NO2, oxalate no. So 1 and 3 are allowed. 1 and 3 are. Which are the following ambidentate? SCN and NO2 minus. Which of the following ligand form a chelation? Chelation is formed by bidentate or polydentate ligand. You know, acetate. Acetate is what? CH3COO minus. It is a monodentate ligand. Oxalate, yes, oxalate is a bidentate ligand. You know, cyanide monodentate, ammonia is also monodentate. Which of the following is not a neutral ligand? Which of the following is not a neutral charge? Aqua, you know, neutral, amine, neutral, ONO minus, NO2 minus. These all are negatively charged ligand. And carbonyl ligand also, you know, neutral charge. Which of the following ligand will not show chelation? Will not show chelation. That means it's not a bidentate or polydentate ligand. What is that? That is option D, SCN. SCN is a monodentate or ambidentate ligand. It cannot form to this. What is DMG? Dimethyl DMG what? Dimethyl It's a polydentate type. You know, EDTA hexadentate, ethane 1,2-diamine, bidentate. A coordination number. What is the coordination number and oxidation state of the element E in the complex? Another same type of question we discussed before. First, we can calculate coordination number. E is the metal, En twice. What is En twice? 2En. And oxalate, the total 6 is the coordination number. So 6 is the starting. What is the oxidation state of the metal? EX. En is neutral ligand. Oxalate charge -2 and nitro charge is -1. Overall is equal to +3. Yes, 6 is the coordination number. 3 is the oxidation state. 6 and 3. Yes, let's go with option A. I think the same one, another question we discussed. Now, identify the statement which is not correct. Coordination compounds are mainly known for transition metal, correct? Because coordination complexes are mainly formed by our d block elements, right? Because of the availability of the vacant d orbital, correct? Coordination number and oxidation state of a metal are same. No. It is not compulsory. Coordination number can be 6 or 4 like that. Oxidation state can be even 0. So here even in the previous case, see, coordination number and oxidation state not compulsory to make it same, right? That can be different. So that is a not a correct statement. Which of the following rule is not correct as per their IUPAC nomenclature? You studied lots of rule for naming coordination compound. Cation is named first and then anion. Of course, always cation name first, then anion. In coordination sphere, ligands are named alphabetically. Yes. Positively charged ligands have suffix 8. What is positively charged ligand, my dear? That is wrong. Ligands are either negatively or neutral charged species, right? Positively charged ligands are not there. And what is the correct IUPAC name of the complex? Let us start. Potassium is first, right? So potassium, now total 5 cyanido, right? So we can say pentacyanido or cyano. Pentacyanido. What is NO? Nitrosyl. So potassium, pentacyanido, nitrosyl. Fe is in the anionic part. Therefore ferrate. What is the oxidation state? 3 potassium charge is 3. Fe charge X. 5 cyanide charge is -5. NO is neutral. Overall 0. X is equal to +2. So where is this complex, my dear? Check it all. Potassium, pentacyano or cyanido, nitrosyl, ferrate 2. Yes, let's go with option A. Now, what is the correct formula of the complex? They ask you name to structure, structure to name. Okay, careful. Tetraamine. What is tetraamine? NH3 4 time. Chloro, that means 1 chlorine is there. Nitro means NO2 or we normally call nitrito N. Platinum, PT is the metal atom. And 4 is the oxidation state and sulfate is outside. We need to get overall charge 4, right? Please check it all. Platinum hexa, amine 0, 1 chlorine -1, NO2 -1, sulfate is -2. Yes, overall we are getting +4. No need to make any adjustment. So where is this complex, my dear? Check it. PT NH3 4 time, ONO, no, and PT NH3 4 times Cl2, 2 chlorine not required. PT NH3 4 times Cl NO2 SO4. Yes, option C is the correct one. Which among the following will be named as dibromido? What is dibromido? Br2. Bis ethane 1,2 diamine. That means what? En twice. And what is the central metal atom? Chromium. And is there any counter ion? Yes, bromide. But overall charge we need to make it 3. Okay. So as per now, let me write chromium X, 2 bromine -2, En 0, 1 bromine. Overall, yes, overall we are getting actually +3. So no need to make any adjustment. So where is this complex? Cr, En twice, Br twice, Br. Option A is correct, right, my dear? Check it all. Bis, right? Bis, yes, En. This is tris. This is, yes, that's all. The formula of the complex again, diamine. What is diamine? NH3 twice. Diamine chloro. Chloro means Cl. Only ethylene diamine. Okay, that means only 1 En. Nitro. What is nitro? NO2. That you can write a random order, no issue. Then what is the central metal atom? Platinum. 4 is the oxidation state and chloride is outside. Let us check it whether 4 is getting or not. So platinum X, amine neutral, chlorine -1, En neutral, NO2 -1, 1 chlorine -1, overall 0. But here, dear all, you will get only +3. But we want to get +4, right? So if you want to make it +4, what we can do it? You can put 2 chlorine here. So it become -2, it become +4. Counter ion, if there, you can adjust the number of counter ion, right? So this is an allowed one. This is an allowed one. So let's go with which option is this? PT NH3 twice, Cl, En, NO2. Yes, option A itself, that is correct. Now the name of the compound is, amine is there, nitrito is there, chlorine is there. Okay, let's start. Pentaamine, right? Total 5 amines are there. Pentaamine, and nitrito. What is NO2? Nitrito N or nitrito or nitro. Then who is the metal? Cobalt is the metal. Cobalt. What is the oxidation state of cobalt? Cobalt X. Amine 0. NO2 charge -1. 2 chlorine charge -2. Overall is 0. X is equal to what? +3. So 3 and outside we have chlorine. So we can write chloride. So check it all. Where is this answer, my dear? Pentaamine. We won't write pentaamino. That's wrong. Pentaamine. Nitro. That's okay. Nitro. Chlorido. No, chlorido is not inside. Pentaamine, nitro, cobalt 3 chloride. Yes, option C. Yes, option C is the correct one, right? Check it all. Which of the following will not show geometrical isomerism? What is geometrical isomerism? Cis-trans isomerism. Correct, my dear? Cis-trans isomerism is given by two complexes. Please note all. Square planar complex will show with the type Ma2B2 type. Whereas octahedral complexes with the type Ma2B4 can show cis-trans isomerism or geometrical isomerism. You check it. This is Ma4B2 or Ma2B4 type. Yes, this will show. But which is the question which will do not show? And this is a type Ma4B2. Check it all. This is En, okay? En twice mean B4 because 4 site it will give you. That will show. And what is this? Ma5B. Yes. This one do not show. What about this one? This is Ma2B2 type. It also shows. Which do not show geometrical isomerism. Option C. Remember, cis-trans isomerism mainly given by square planar and octahedral complex. Square planar the type Ma2B2, octahedral the type Ma2B4 or Ma4B2. Clear? Let's go for question number 51. For the square planar complex MABCD, what is meant by MABCD? M, metal connected to 4 different ligands. The type MABCD, this point you please keep in mind all of you. In square planar, we already discussed. The type Ma2B2 show cis-trans isomerism. But the type MABCD, if in square planar complex, if all the 4 ligands are different, then it will show total 3 isomers. Number of possible isomers are 3 isomers. Keep in mind, in square planar complex, if all the 4 ligands are different, it will show you total 3 types of isomers. Which of the following complex species is not expected to exhibit optical isomerism? Optical isomerism, in order to show, first condition, bidentate ligand should be there. Bidentate ligand should be there. Very simple. This is a bidentate ligand. Option this one, you check it all. This one no bidentate ligand. Both are monodentate ligand. It is a type Ma3B3. We discussed before. Ma3B3 show which isomer? Fac and mer isomer, facial and meridian. It do not show optical isomerism. Now, this complex shows 2 geometrical isomerism, cis and trans. Let me draw the cis and trans isomer of this one, my dear. You know how to place it, cis isomer. Cis meaning NH3 and Cl. Okay, let me place it NH3 and Cl. Then we have En and En. Let me place it like this. This is cis isomer. And trans mean, how can we draw it? Trans mean we can place like this one. We can place it one NH3 here, the Cl here, and other 2 side En. This is what? Opposite, therefore it is what? Trans. This is the cis isomer, this is the trans isomer. And what is the question they asking you? Question which statement is correct? Trans isomer will show optical isomerism. See, trans isomer is this one. If you take the mirror image of this one, you will get the same image and that will be superimposable. If it want to be optically active, the mirror image should be non-superimposable. So trans isomers are basically not optically active because their mirror image is same, they are superimposable. But this is cis isomer. If you take the mirror image of this one, it will be another image, so they are non-superimposable, and cis isomer will show optical isomerism. Keep in mind all of you, among cis and trans isomerism, cis isomerism will show the optical isomerism, because cis isomers are, their non-superimposable mirror images. Next question, two isomers are given here with the type MA3B3. Hope you get it. MA3B3 mean it is FAC and MER isomerism. And the figure is also given here, the isomerism classified. Dear all, this is FAC, this is MER. What is the difference between them? FAC with the meaning, the three ligands will be adjacent. FAC meaning three ligands should be adjacent. If you connect all these three ligands, you will get a face there. Can you get a triangle face there? That's called FAC isomer. MER isomerism means two ligands adjacent, one ligand other side. Means if you connect, you will get a hemisphere. That's called meridian. So three ligands adjacent, that will be FAC. Two ligand adjacent and one ligand other side, that will be MER. So one is FAC and second one is MER isomerism. Question, identify the isomerism. So first one is FAC, second one is MER. Which of the following compound exhibit linkage isomerism? As I told you, in order to show linkage isomerism, there should be the presence of ambidentate ligand. Where is an ambidentate ligand? This is bidentate, this is monodentate, this is monodentate. See, NO2 is there. What is the NO2 ambidentate ligand? ONO. Yes, C can form linkage isomerism. This complexes, you can see here, two coordination spheres are given here. Two coordination sphere mean directly we studied that will show coordination isomerism. And what is the isomer of this one is given here? Tell me, check it all of you. Here what is happening? This platinum and copper get interchanged. The species are interchanging between two coordination sphere, what we call coordination isomerism. And okay, next one. Which of the following isomer will give white precipitate with the barium chloride? Barium chloride, if you are treating, if it forming white precipitate, mean barium sulfate is the precipitate. So where is sulfate outside? Here. So answer is B. What is the point? If a compound, when you treated with a barium chloride, if they are saying that there is a white precipitate, the white precipitate is nothing but barium sulfate. Barium sulfate. So this barium combined with this sulfate, here bromine is the present, not give you white precipitate. Barium chloride, if you are treating, white precipitate is forming, then barium sulfate is the species. Now, few isomers are given below. Mark the correct statement regarding this. CrH2O 6 times Cl3. This example we discussed in our hydration isomerism. And one here, what happened to here H2O 6 times, here H2O 4 times, and then here actually one H2O outside. Here one chlorine will be there, okay, and H2O 4 times Cl2. So here 2 H2O outside, and chlorine, okay. So when you check these formulas, when you check the formula, their molecular formula are same, but here 6 H2O as ligand, 4 H2O as ligand, and here we can place it the another isomer, okay. I'm just marking a correction here. H2O 3 time, here we have H2O 6 time. Okay, let me just arrange these complexes once again, okay, my dear. So complexes are, there is a small mistake, I think. CrH2O 6 times Cl3, one complex. Here how many H2O as ligand? 6 H2O as ligand. Now let me place one H2O outside, one chlorine inside. So CrH2O 5 times Cl, Cl2, one H2O out. Now 2 water outside, 2 chlorine inside. CrH2O 4 times Cl2, 1 Cl outside and 2 H2O outside. These complexes we studied under the area hydrate isomerism. Because of the hydrate isomerism, it showed different color. We studied that this complex is violet in color, this complex is gray-green in color, this is dark green in color, right? Because of hydrate isomerism. So question they are asking you, 1, 2, 3 are hydrate isomer, 1, 2, 3 are coordination. They are actually belongs to which isomerism? Okay, you cut these complexes, you select these complexes as the question. 1, 2, 3 are hydrate isomerism. Because of hydrate isomerism, they shows different colors also. That is one another previous question. Check it all of you. Which of the following pair of isomer is not correctly matched? Isomerism questions are very sure important question, my dear, be careful. Which is not correctly matched, okay? This, see, this is two coordination sphere given, see coordination sphere given, that is what coordination isomerism, correct. And this is what linkage isomerism mean ambidendate ligand or not, check it. Here NO2 is there, here ONO is there, yes, correct. And here they are saying that coordination isomerism. Is it coordination isomerism? No. This is the correct answer. See, coordination isomerism means there will be two coordination sphere from which the species are interchanging. Here you see this is one species, this is one another species. No. What about the last one? Ionization. Yes, see that bromine and chlorine get interchanged here. That is our ionization isomerism. So what is the answer? C. And CrCl3 6H2O exist in different isomeric form which show different colors like violet, green and all. This is due to what? Hydrate or solvation isomerism. I just discussed now the complex, which one? CrH2O 6 times Cl3, violet color. If H2O outside, grey green, dark green. The color of isomerisms, different compounds having different color here is because of presence of H2O ligand in different number. That is hydrate isomerism. Match the column 1 with the column 2. All of you carefully notice. This column 1, which isomerism is this? You can clearly notice that two coordination spheres are given. Two coordination sphere mean coordination isomerism. Then second one, this is given NO2 ClBr. You know Cl and Br can interchange, right? Cl and Br can interchange. They can show ionization isomerism. But ionization isomerism I think is not given here. Okay, let us go with another. Can you able to see En twice is there? Even NO2 is there, my dear. NO2 is there. NO2 is what type ligand? Ambidendate ligand. So it can show linkage isomerism. And another one, let us possible. PTEN twice Cl2. This is a type Ma4B2. Ma4B2 show cis trans isomerism or geometrical isomerism. And what about the last one? CN2 NH4 twice. Then optical isomerism is remaining, right? Okay. Then wait all of you. Then we have to make some rearrangement here. Not matching. So A we can definitely match with the coordination isomerism because two coordination spheres are given here. That is coordination. I think that is only one option is given, C. A is matching with one third one. Then B they said with the fourth one. Okay, NO2 is there, so linkage isomerism, that's also correct. C is given as which one? Optical. Okay. En twice is there, right? This is a type which one, my dear? Ma4B2. We studied Ma4B2 can show cis and trans isomer, where cis isomer is optically active. Yes, so optical isomerism possible. And this is a type of Ma2B4. Yes, it can show which one? Geometrical isomerism. Yes, correct option. C is the most suitable one. Next one, mark the incorrect statement. Inner orbital low spin complexes involved in D2sp3. What all cases we studied in octahedral complexes? We studied octahedral complexes can be the hybridization D2sp3 or sp3d2. If it is D2sp3, they are called inner orbital complex. Inner orbital complexes are also called low spin complexes. sp3d2 mean they took outer d orbital, so therefore they are called outer orbital complexes or high spin complexes This is the theory we studied according to VBT. Check it. Inner orbital low spin complexes involve D2sp3. Correct. They are asking which is incorrect. Outer orbital, that means high spin complexes involve sp3d2. Correct. Tetrahedral complexes generally involve dsp2. No, tetrahedral complexes, what is hybridization, dears? sp3. So this is the incorrect statement. Which of the following facts about the complex is wrong? So they are asking about the shape and all. So let us calculate faster. They are given that CrNH3 6 times Cl3 is given as the complex, right? Which is wrong? That's a question. Let us go for the complex. You know the step 1, step 2, step 3 calculation of VBT. Let me take the central metal atom chromium. Chromium atomic number is 24. We can write it as argon 4s2 3d4. No need to interchange the half-filled configuration. Okay, anyway you are going to remove electron, right? Here what is the charge of chromium? Chromium X, amine 0, 3 chlorine minus 3, overall 0, X is equal to plus 3. So chromium charge is plus 3. What do you mean by plus 3? Remove this 2 and from this one you will getting 3d3 4s0. 3d3 4s0. And you know amine is a strongest ligand. If amine is a strongest ligand, we have to pair the electron, right? D3. D3 means what? 1, 2, 3 and 4s is free now. See, if you pair, you know, amine is a strong ligand. If you pair it, it is very clear it is an octahedral complex. Why it is an octahedral complex? Because the coordination number is what? 6. If it is an octahedral complex, either it should be sp3d2 or d2sp3, correct? So here, if you consider amine is a strong ligand and if you pair it, these all electrons get paired, it will become 3d orbital will be free. So it comes starting with a d3 something, such hybridization not there. So even though there is a strong ligand, we studied some exceptional cases. Even though amine is a strong ligand, here no need to pair it. So you can go to the hybridization, which one? You can take 1, 2, 3, 4, 5, 6. What is hybridization? D2sp3 can be selected. D2sp3. So check it all. The complex involved D2sp3 hybridization and is octahedral in shape. Yes, correct. The complex is paramagnetic. Yes, that's having unpaired electron, correct. The complex is an outer orbital complex and complex give white precipitate with a silver nitrate. Can it give white precipitate with a silver nitrate? Yes, right? Is this complex give white precipitate with a silver nitrate? Because a silver nitrate, if you treated silver combined with the Cl, you will get AgCl. Yes, white colored precipitate. So which is the wrong statement? C, it is the complex is an outer orbital complexes. No, the hybridization is come as D2sp3. So it should be a inner orbital complex. Now the complex ion which has no d electron in the central metal ion atom, where there is no electron in d orbital. Check it. First complex, let me take it as MnO4, which is the central atom Mn. Mn atomic number is 25. We can take it as argon 4s2 3d5. Here manganese charge you calculate, my dear. Mn charge is X. You know, 1 oxygen charge is -2. So 4 oxygen -8. Overall -1. X is equal to +7. Correct? So plus 7 mean remove all those 7 electron. See, there is no d electron. So all the d electron is lost, right? So there is no d electron. Option A can be the correct one. What is the question, my dear? Once again, the complex ion which has no d electrons is, no d electrons means what? The d orbital contain no electron. Here Mn is the central metal atom. Mn charge is +7. +7 mean all those 2 and 5, 7 electron gone. There is no d electron. Now give reason for the statement why NiCN4 2- is diamagnetic while NiCl4 is paramagnetic. Very simple question, my dear. NiCN4, which is the ligand here, cyanide. You know, cyanide is a strong ligand, whereas Cl is a weak ligand. So strong ligand if present, you know, electrons undergo pairing, there won't be any unpaired electron. So it can be diamagnetic. If there is a weak ligand, no pairing of electron, so enough unpaired electron will be there. It is paramagnetic. Where is that answer? NiCl4 2- no unpaired electron, no. NiCN4 2- no unpaired electron are present, while NiCl4 2- 2 unpaired electrons are present. NiCl4 2- shows a DSP to hybridization, hence it is paramagnetic. No, NiCN4 2- shows sp3 hybridization, hence it is show diamagnetic. No, mainly the diamagnetic and paramagnetic is based on what? The presence of strong ligand and weak ligand. So this complex, no unpaired electron are present, while in NiCl4 2- 2 unpaired electrons are present. Therefore it is what? Paramagnetic and diamagnetic. COF6 3- is, they are asking you the geometry and all. Okay dear all, let us calculate faster. What is the species? COF6 3-. Which is the central atom? Cobalt. Cobalt atomic number is 27. So we can write it as argon 4s2 3d7. What is the cobalt oxidation state? X, 6 fluorine minus 6, overall charge minus 3, X equal to plus 3. So cobalt charge is plus 3. What is meant by plus 3? Lose this 2 and 1. So remaining is 3d6 and 4s0. Okay, 3d6, let me write it here. How you write 6 electron? 1, 2, 3, 4, 5, 6 and 4s is free now. You know, fluorine is a weak ligand, so no pairing happen. So total 6 vacant orbital we need because 6 ligands are there. Only 1 is free. So let me take it after 4s who is free, 4p, after 4p which is free, 4d is free. So let me take 1, 2, 3, 4, 5, 6 orbital. What is hybridization? sp3d2. sp3d2. Check it all. Is it paramagnetic? Yes, it's highly paramagnetic because more unpaired electrons are there. So they are paramagnetic and undergo sp3d2 hybridization. Yes, correct. No, diamagnetic, paramagnetic and undergo sp3d hybridization. No, diamagnetic, no. So VBT related questions are very important, my dear. So step 1, you know, ground state. Step 2, you know, oxidation state. Step 3, identify the ligand, whether it is strong or weak. As here it's a weak ligand, so no pairing. So we got the hybridization sp3d2. Next, which of the following has largest paramagnetism? Largest paramagnetism means they contain more number of unpaired electron. Okay, more number of unpaired electron. Option A, central atom is chromium. Chromium is 24. We can write it as argon with the 4s2 3d4. Here chromium charge is 3 plus. 3 plus means this 2 and 1 goes. 3d3 is remaining. And H2O is a weak ligand, so this 3 electron won't pair it. So there will be 3 unpaired electron. First case. Second case is given as iron. Iron atomic number, you know, 26. So configuration we can write it as argon 4s2 3d6. And here Fe charge is 2 plus. So Fe 2 plus mean lose these 2 electrons. So 3d6 is remaining. And you know H2O is a weak ligand, so 6 electron, how they occupy? 1, 2, 3, 4, 5, 6. There are 4 unpaired electrons. All right. Let us go to the third system. Copper is the metal atom. You know, copper atomic number is 29. So that is argon with 4s2 3d9. And here copper charge is 2 plus. So this 2 gone, 3d9 is left. You know, aqua is a weak ligand. So 9 electron, how they exist, my dear? 1, 2, 3, 4, 5, 6, 7, 8, 9. Only 1 unpaired electron is there. Only 1 unpaired electron. And last one is given as D, that is zinc atomic number is 30. So the configuration is argon 4s2 3d10. Here Zn charge is 2 plus. So Zn 2 plus means these 2 electron gone. They are all D10. D10 means all the orbitals are, which one, how many? 2 electrons are there. There is no unpaired electron. Question, which of the following has largest paramagnetism? Largest paramagnetism means the one which contain more number of unpaired electron. Where you can able to see more unpaired electron? First 3, 4, 1. Yes, that B is the more one. Now, using valence bond theory, the complex can be described as, what is the complex? CrH2O 6 times 3 plus is the complex. Let us start the structure. Chromium is the metal atom. Its atomic number is 24. So configuration is argon, then 4s2, 3d4 is the configuration. Here chromium charge is which one? 3 plus. So chromium 3 plus means this 2 and this 1 gone. 3d3 and 4s0 is remaining. H2O is a weak ligand, so electrons do not undergo pairing. So we can write 1, 2, 3 and 4s is here. This is 3d, this is 4s. Total 6 ligand we have to place it. So 6 vacant orbital we need. We have only 3 now. So after 4s we can take it 4p. So 1, 2, 3, 4, 5, 6 we can take it. So you will get sp3d2 octahedral complex, right? So what is the answer? It is sp3d2, and you know sp3d2 means outer orbital complex and high spin. I think which can be described as option A is correct, right? sp3d2 out and its outer orbital complex and paramagnetic. Yes, unpaired electrons are there. So all are related to VBT. Now, which of the following complexes will show maximum paramagnetism? I told you maximum paramagnetism means they contain maximum number of unpaired electron. What do you mean by D4? D4 means d orbital contain 4 electrons. So what is the unpaired electron? 4. D5, you know, D5 means the how the electron access 1, 2, 3, 4, 5. The number of unpaired electron is 5. D6, what do you mean by D6? D orbital contains 6 electron. 1, 2, 3, 4, 5, 6, only 4 unpaired electron. What about D7, my dear? D7 means 1, 2, 3, 4, 5, 6, 7, only there will be 3 unpaired electron. So which of the following complexes will show maximum paramagnetism means the one which contain more unpaired electron, that is D5, 5 unpaired electrons are there. Hope you can follow me. And what is the electronic configuration of this complex on CFT, the theory, T2G and EG, how to place the electron? The complex is given as Cu, central metal atom is copper, copper atomic number is 29. What is the configuration? 4s2, 3d9 with argon. Here copper charge is 2 plus, so 2 plus means this gone. What is remaining? 3d9. And amine is a strong ligand, my dear. Strong ligand mean how 9 electron access? 1, 2, 3, 4, 5, 6, 7, 8, 9. Already 9 electron, even if you pair it, it will access like this, correct? So how you are going to split this one? How you are going to split this one? In octahedral complexes, how the splitting is happening. First 3 orbital goes down. First 3 orbital goes down. Last 2 orbital goes up. This is called T2G and this is called EG. How many electron in T2G? 6 electron. EG only 3 electron. T2G 6, EG 3. Option B can be suggested. T2G 6 and EG 3. This is the crystal field theory related question. Now, what is the correct energy level diagram for the complex here? Again, cobalt is the metal, 27 is the configuration. Cobalt 27, what is the configuration we can write? We can write argon with 4s2, 3d7. Here cobalt charge you calculate all of you, you will get cobalt 3 plus. Cobalt 3 plus means this 2 and this 1 gone, remaining 3d6 and 4s0. And 6 electron, how you can write it? 6 electron, normally we can write 1, 2, 3, 4, 5, 6. But cyanide is the ligand. Cyanide is a strong ligand, so electrons undergo pairing. How 6 electron get pair, my dear? 6 electron, why like 2, 2, 2. Now you break down. Now you break into what? First 3 goes down. First 3 goes down. Last 2 up. T2G 6 electron. Here EG no electron. Where you can find that configuration, my dear? Check it all. Check it all of you. That is 6 electrons are there. T2G 6, EG 0. That is option B. See, T2G 6, EG no electron. Because cyanide is a strong ligand. Electrons undergo pairing. Now FeF6 3 minus is paramagnetic due to the presence of unpaired electron in the complex. The 5 electrons remain unpaired because. Why it is paramagnetic? Because fluorine is a weak ligand. Since weak ligand present, they do not undergo pairing, so they exist as unpaired electron. So fluorine is the most electronegative element. That's a correct statement, but not the reason here. Fluorine is a weak ligand. So fluorine is a weak field ligand, hence does not cause pairing of electron. Yes, therefore. Now, the increasing order of their crystal field splitting strength. We studied spectrochemical series. One question in part 1 video we already discussed. Can you tell me what is the correct order of their crystal field splitting energy or the spectrochemical series? What is the correct order? Carbonyl is the most strongest ligand, then cyanido, then amine, then aqua, then only halogen comes. C is the correct order. Study the spectrochemical series thoroughly, my dears. The geometry possessed by this complex is, okay, let us calculate. Here nickel is the central atom, 28 is the atomic number. We can write it as argon with 4s2, 3d8. Here nickel charge is 0, right? Because carbonyl is a neutral ligand. Nickel charge is 0, no oxidation state. So let us go for carbonyl, my dear. Carbonyl is a strong ligand. If there is a strong ligand, electrons undergo pairing. So how D8 and 4s2, what happened? These 2 electrons also come inside 3D, so it will become 3D10. 3D 10 means how you can fill the electron. 2, 4, 6, 8, 10. All outermost electron come inside and get paired. So total, 4 ligands you have to accommodate. 4 ligands if you want to accommodate, 4 vacant orbitals are required. 3D already full. After that we can take it which one? 4s and 4p we can take it. So 1, 2, 3, 4. What is hybridization? sp3 is the hybridization. sp3 means what is the shape, my dear? Tetrahedral is the geometry. According to VBT. These all are related to VBT and CFT. Now CRC bond in the compound CrCO6 shows pi character due to. We studied that Cr, metal when combined with the carbonyl ligand. Any metal combined with the carbonyl ligand, they have a ability to form pi bond. Pi bond means 1 sigma bond, 1 pi bond. And in the double bond, 1 sigma bond and 1 pi bond. So metal carbonyl, a special case we studied. Carbonyl ligand have an ability to form double bond with the metal, and the extra bond, what we call it as synergic bond, right? Synergic bond or self-strengthening bond. So what is the question? The CRC bond in compound shows pi character. That is because of what? Synergic bonding. That is because of synergic bonding. That is the extra pi bond is called what? Synergic bond. Question number 76. Mark the incorrect match. If we studied in biology, where these coordination complexes are using in biological system, we studied hemoglobin, iron is the central atom. Chlorophyll pigment, magnesium is the central metal atom. And vitamin B12, cobalt is the metal atom. And one more I am introducing you, insulin, zinc is the metal atom. Hemoglobin, iron, it is correct. Vitamin B12, cobalt is correct. They are all chlorophyll pigment, not chromium, it is magnesium. So this is the incorrect match. Match the column 1 with the column 2. Okay, let us go for that. First one. Estimation of hardness of water. We studied hardness of water is calculating by the titrating with the EDTA. So this is with the A with the 2, A with the 2, option B. Anyway, detection and estimation of nickel. Qualitative analysis we are using DMG, dimethyl glyoxine, DMG, this one. This is B. Electroplating is there, cancer treatment is there. I think the cancer treatment you may study cisplatin, right? That is D. And electroplating is which one? Potassium dicyanoargentate. So basically, except this electroplating, all others are mentioned in textbook. So that overall answer is A2, B3. Yes, correct. Now both geometry and geometrical means what? Cis-trans and optical isomerism are shown by. Both geometrical and optical isomerism are shown by the type, remember, Ma2B4 type. Ma2B4 type can show both geometrical and optical, especially the cis isomer. Okay, which type is this one? This is Ma5B, no, Ma4B2, Ma, not that. So I think option A is correct. And remember, in order to show optical isomerism, bidentate ligand also should be there. Therefore, I selected this one. See, this type is given as COEN twice, Cl twice. See, this complex is given the type Ma4B2. Why Ma4? Because En is a bidentate ligand. So, En twice mean 4 times. Okay. This type, let me draw the shape. Okay, CO. This will show cis isomer, right? Ma4B2 shows geometrical isomerism. That is very clear. But how it show the optical isomerism? Let me draw Cl, Cl. This is what? En, En. This is the cis isomer. And if you place one Cl up, one Cl down, En, En this side, it will be trans. Cis isomer, when you take the mirror image, it will be different and they are non-superimposable. Correct? So the type Ma2B4 with a 2 bidentate ligand, definitely they show geometrical isomerism as well as optical isomerism. So option A is the correct answer. Why it is not? This is a type Ma5B, do not show. This is a type Ma4B2. It will show cis-trans isomerism, but optical isomerism cannot show because no bidentate ligand. This can show optical isomerism because bidentate ligand is there, but it cannot show geometrical isomerism. The color of the coordination compound depend on the crystal field splitting. What will be the correct order of the adsorption of their wavelength? Wavelength. Careful all of you. Wavelength. You want to arrange the complexes, these complexes in the order of their wavelength. You studied in 11th grade, energy is related to what? Wavelength, right? Energy E equal to hc by lambda. So energy is inversely proportional to which one? Wavelength, correct? Energy is inversely proportional to wavelength. Careful. So higher the energy, which energy? You know, crystal field splitting energy. Stronger the ligand, or you remember like this one, my dear, strong ligand having less wavelength. Stronger the ligand, higher energy, so less wavelength. You know, amine is there, cyanido is there, aqua is there. Which is the most strongest ligand? Cyanide, then amine, then aqua. So energy order, if you're writing, cyanide is strong, then amine is, then H2O is weak ligand. So if you want the wavelength, opposite order, aqua come first, then amine, then only CN comes. So where is this, my dear? H2O, NH3, CN, option C. So if they're asking you the wavelength, you know, wavelength is related to the energy inversely proportional. Careful. So stronger the ligand, you know, if you want to know that spectrochemical series, we have to know. So stronger the ligand, stronger the higher the energy. Higher the energy, lesser the wavelength. So, you know, aqua is a weak ligand, therefore more wavelength. Okay, they are asking wavelength order. Now, indicate the complex ion which shows geometrical isomerism. That means cis trans. We know geometrical isomerism is given by the type Ma2B2 in square planar, Ma2B4 in octahedral. So, what is this? Yes, this is our type Ma4B2. Go with this one. Other cases are not belongs to our category. What is the correct IUPAC name of cisplatin? What is cisplatin? Anti-cancer drug. What is the formula of cisplatin? PTNH3 twice, Cl twice. This is the complex called cisplatin, my dear. What is the name of cisplatin? Diamine, right? Diamine. Then 2-chlorine, right? Dichlorido. Diamine, dichlorido. And what is the metal? Platinum is the metal. What is the oxidation state? Platinum X, amine 0, 2-chlorine minus 2, overall 0, X equal to plus 2. We can place 2 here. So where is the answer? Diamine, dichlorido, platinum 2. Yes, let's go with option A, right? Cisplatin means it is an anti-cancer drug. Formula please memorize all. Diamine, dichlorido, platinum 2. Next one. What is the experimental value of magnetic moment? How to calculate magnetic moment? Magnetic moment is calculated by the equation root of n into n plus 2 Bohr magneton. Where what is n? N is the number of unpaired electron. What is the complex given? FeCN6 4 minus. They all calculate the number of n value. How to calculate n? Apply VBT. Which is the central atom? Iron. Iron atomic number 26. So we are getting argon with a 4s2 3d6. Here Fe charge you calculate, you will get 2 plus. Yes or no? FeX 6 cyanide minus 6, overall charge minus 4, x equal to plus 2. So Fe 2 plus means these 2 gone. What is remaining? 3d6. You know, cyanide is a strong ligand. So strong ligand if present, these 6 electrons undergo pairing. So you will get 2, 2, 2. Is there any unpaired electron? No unpaired electron. Unpaired electron 0 mean magnetic moment also 0. Root of 0 into 0 plus 2. Option C can be the answer. So root of n into n plus 2 is the equation to calculate magnetic moment, and the n value represent the number of unpaired electron. Next one. State the number of unpaired electron in the metal K4NiCN4. Okay. Who is the central metal atom, my dear? Central metal atom is nickel. Nickel atomic number is 28. We can write it as argon 4s2 3d8. Here nickel charge value calculating. You know, 4 potassium outside. So 4 potassium charge 4, nickel x, and 4 minus equal to 0. So x equal to what? 0. Here nickel no oxidation state. Okay. You know, cyanide is the ligand. Cyanide is a strong ligand, so all electrons get paired. So even the 4s2 electron also come inside, it become 3d10. 3d10 means how you fill the electron, my dear? 2, 4, 6, 8, 10. Is there any unpaired electron? No unpaired electron, because all electrons get paired. So let's go with which one? Option D. So in this case, no unpaired. Question state the number of unpaired electron, non-unpaired electron. What is the formula of the complex? Potassium. What is potassium? K. Dicyanido. What is dicyanido? Cn twice. Bisoxalato. That means OX twice. Nickelate. Yes, nickel. Okay. 2. What is the overall charge? 2. We need to get it. Let me check it. As per now, it is correct or not. As per now, I placed only one potassium, so charge is 1. Nickel X. 2 cyanide charge is -2. 1 oxalate -2, 2 oxalate -4, overall 0. You will get it as X is equal to +5. But we need to get it as +2. If you want to make it +2, let me put it 3 potassium outside. So this will be 3. So overall it will be how much? It will be +3, right? How much we need to get it? Here 6 minus 3, not enough. I think 4 potassium is required, right? K4 is required. Then only it become a 4. So 6 minus, yes, it will be, now it will give you +2. So there should be 4 potassium outside. K4 NiCN twice, OX twice, right? Option C can be the correct answer. Check it all of you, correct or not? Please cross check it, okay? So formula of potassium dicyanido bisoxalato nickelate. Okay, 4 potassium should be outside, then only the charge overall it will be 2. So here 4 potassium, excess -2, -4, overall -2 here, yes, +2, correct. Next one, which is present in metal carbonyl? Which is present in metal carbonyl? What is metal carbonyl? Metal with the carbonyl ligand. We studied there is a chance to form double bond. One bond is single, one bond is pi, the synergic bond. So which is present in metal carbonyl? We can say option C, metal carbon sigma bond is there, metal carbon pi bond is also there. What is that pi bond is called? Synergic bond. How many ions are given by this complex? What is the complex given here? CONH3 5 time Br and then Cl2. How many ions can produce by this one? Let me write this complex is 1 time, chlorine is 2 time. You know these 2 come from here, 1 come from here. So 1 CONH3 5 time Br is there with the charge 2 plus and 2 chlorine with the charge -1. 1 plus 2 sorted, it will giving you how many ion? 3 ions can be given by this complex. What is the IUPAC name of this complex? Potassium, starting with the K, right? Starting with the potassium, okay? So potassium cyanido, dicyanido. You know silver, when it is present in the anionic part, it's called argentate, right? Argentate. What is the oxidation state? Only 1 potassium, silver X, 2 cyanide -2, overall 0. X is equal to what? +1, right? Where it is given, my dear, check it all. Potassium dicyanido, argentate 1, right? Option C is the correct answer. Now, what is the IUPAC name of the complex? K2Ni. See, there is a small difference, okay? This is KAG, here K2Ni. So, here potassium is again outside. So, potassium, total 4 cyanido, right? So, tetracyanido, nickelate, because nickel is in anionic part. Calculate the charge, I think you will get 2. Potassium tetracyanido nickelate 2. Potassium tetracyanido nickelate 2. Option B is the correct, right? Yes. Next one. In the following chelating ligand, which is a chelating ligand, right? Chelating ligand means it should be bidentate or polydentate. OH is monodentate. Yes, this is what? This is our EN ligand. Ethane 1,2-diamine is our bidentate ligand. It's monodentate. What is the coordination number in this complex? What is the coordination number? Here all. Chromium is the metal. It is connected to oxalate. How many oxalate is there? 3 oxalate. You know, oxalate is a bidentate ligand. So that will provide total 1, 2, 3, 4, 5, 6. 6 is the coordination number. What is the oxidation state of Fe in this one? Simple question. 3 potassium, 1 potassium plus 1, so 3 potassium plus 3, iron X, 6 cyanide minus 6, overall 0, X equal to plus 3. Yes, so when you're doing this question, when I'm giving you one question, pause the video, find your own answer and cross check it, okay? Now, what is the name of this complex? Okay, start. Potassium is outside, so let's start with potassium, 3, right? So trioxalato, what is aluminium is in anionic part, right? So aluminate. Potassium trioxalato aluminate. And what is the overall charge? 3 potassium 3, aluminum X, 3 oxalate minus 6, overall 0, X is equal to what? Plus 3. So we can write it to what? 3. So where is the answer? Potassium trioxalato aluminate 3, right? I think option A is correct. Yes, fine. Now, predict the number of ions produced per formula for the complex COEN thrice, Cl thrice. This complex, how many ions can produce? Let me write this complex 1 time, this is 3 time. This 3 come from here, this 1 come from here. So we will get 1 complex COEN thrice, overall charge 3 plus, and 3 chlorine with a charge minus 1. 1 plus 3, total it's giving you how many ion? 4 ions can be produced. So total number of ions 4. When 1 mole of, what is the complex given? COCl3 5NH3. Okay, the complex formula is given as COCl3 5NH3 is the formula given, is treated with the excess of silver nitrate giving you 2 moles of AgCl. Remember all, 2 mole AgCl produced mean there should be 2 chlorine outside. That's the meaning. So what is the answer? Option B. This is 1 chlorine outside, so it will give you only 1 AgCl. Okay, that's it. So when 1 mole of this complex treated with the excess of silver nitrate, 2 moles of AgCl were precipitated. What is the formula of the complex? Point is very simple. If they're giving 1 mole AgCl mean there is 1 chlorine outside. 2 moles AgCl mean 2 chlorine outside. That's it. Option, only 2 moles AgCl, option B. Correct. Now, the absorption maxima of several species are given here. You can able to see some compounds are there. Its a wavelength is given here. Okay, this is what? The wavelength, lambda. Lambda 474, so 475 nanometer, 310 nanometer, 490. Question, what is the crystal field splitting? Wavelength, how related to energy? Energy is inversely proportional to wavelength. Means higher the wavelength, weaker the ligand. Similarly, lower the wavelength, stronger the ligand. So this one, which one having weakest wavelength? This one. So second one having, strongest ligand. Yes, this is cyanide is the strongest ligand. Then amine is strongest ligand. Then aqua. Correct. So lesser the wavelength, stronger the ligand, more splitting. So question, which one? The crystal field splitting is maximum in no doubt. Which one? COCN6 3 minus. Option B. Remember, stronger the ligand, more the splitting. Right. Next, assertion reason, one question I am just introducing here, the assertion. The complex ion trans, what is the complex given here? COEN twice, Cl twice, whole plus, transform, okay, transform, is optically active. My dear, it is wrong. It is wrong. Why? I am drawing the structure. CO, how to place the trans isomer. Trans mean Cl opposite, En opposite, right, with the 2 plus 1 charge. If it want to be optically active, you take the mirror image. If you take the mirror image, they are superimposable, right? They are same. So trans isomers are generally optically inactive, not optically active. Only cis is optically active. It is an octahedral complex. Yes, it's very clear. Total 6 is the coordination number, so it is an octahedral complex. So complex ion trans is optically active, that is wrong. So assertion wrong, reason is correct one. Now, in the coordination number, what is the coordination number of this complex? COEN thrice 3 plus. What is the coordination number? I think students, you are getting the answer very fast. It is 6, right? Because cobalt connected to En thrice. You know, 1 En provide 2 sigma bond. So 3 En provide 6 sigma bond. Coordination number is 6. On adding silver nitrate solution to 1 mole of this complex, palladium Cl2,4NH3, 2 moles AgCl formed. I told you 2 mole AgCl formed mean 2 chlorine should be outside. Okay, the secondary valency of palladium in the complex will be, what is the complex formula given? Palladium Cl2,4NH3. They are all, when they treated with a silver nitrate, they are getting 2 mole AgCl. 2 mole AgCl formed mean there should be 2 chlorine outside. So what is the formula? PdNH3 4 times Cl2. 2 chlorine should be outside. Correct? Finish. Now the question, what is the secondary valency? What do you mean by secondary valency? You know, primary valency gives the oxidation state. Secondary valency gives the coordination number. So they are asking you coordination number. Here, palladium connected to 4 amine. You know, amine is a monodentate ligand, right? So 1 amine provide 1 sigma bond. So what is the total number of sigma bond here? 4. Now, which metal is present in vitamin B12 cyanocobalamin? Already they given the name cyanocobalamin. Cobalt. Cobalt is the metal present in which one? Vitamin B12. Fe3 plus cation gives a Prussian blue precipitate. Prussian blue precipitate on addition of potassium ferrocyanide solution due to the formation of. We discussed the application of coordination compound, the qualitative analysis. How they are checking the presence of Fe3 plus ferric ion, my dear. They treat the compound with a ferric ion with a compound we studied in class K4FeCN6, potassium hexacyanide 2. And that will give you a Prussian blue colored complex. They are asking you the formula of the Prussian blue color. Fe4, here you are getting K4, here it become Fe4, FeCN6 whole thrice. This is the Prussian blue colored complex. If you are getting this Prussian blue color, you can confirm that the given compound contains ferric ion. So where is that? Fe4, FeCN6 thrice, yes. Okay, so and I think one more thing you studied that nickel presence, how you find nickel react with the DMG, dimethyl glyoxime, you will get a rose red precipitate, right? Rose red precipitate, you will get it, which indicate the presence of nickel. We studied under qualitative analysis. Hope it's, I think, the almost area of the chapter. Coordination compounds we completed. Study thoroughly the entire concepts once again, especially IUPAC naming, Werner's theory, VBT, crystal field theory, color, the metal carbonyl cases, isomerism, and which will conduct more electricity, the wavelength questions and all, energy relation with the wavelength. Study spectrochemical series, the application of coordination compound, and then go for your examination. Everything will be all right. So please practice the theory once again first, then go to the questions. All the best.